Okay, folks, I don't know what's the problem. Twitch is not streaming properly right now, so I'm just going to record this. What have I got? I've got 5. I need 6. Oh shoot! I lost my. Did I not actually save 6? Come on, for real? Serious? There's 6. File, save as BMP picture, and this just might be my my internet, but I don't know what the problem is. Twitch has done a few funky things for me in the past, and let's face it, nobody actually watches these live anyway. It's not like I have a gamillion followers, so there shouldn't be anything wrong with me just recording this. Okay, 4539 done. I do want to get to the point where we can analyze all of these in proper fashion. There's 7. Okay, I need 2 more. 2 more, folks. 2 more. 8. Where's an 8? There's an 8. An 8 might actually be quite high on the non-black pixel front. Okay, we'll save this. This is super exciting. Okay, 1 more. You could feel it. This is the ultimate. Now, here's a 9 right there. (45 by 39). So hopefully after all of this, we'll be able to tell that indeed there is a fingerprint that we can rely on using the black pixels. So there we go. Now I have to set all of these to copy to the output directory. That's already done. That's already done. We want to copy this all the time. This all the time. I wonder if I can do that and say copy always. Perfect, it's done. So now we're going to create a table. So let's do it. So what I'm going to do is 4, and we're going to start off at 0. We're going to say less than or equal to 9. We're going to add, so these numbers are going to go from 0 to 9. We're going to save our image equals a new bitmap, and it will be, from the file, digits slash, and then in curly brackets I. So that means it's going to resolve I. So if I was 3, 3 is actually going to be put there. And from that, I hope you can see that that will create the file names 0 through 9.bmp, one at a time. We don't need that one anymore. So that will get that in the image, and then we will say of our black percent equals get percentage of black from the image. Okay. And then I'm going to write this out, console.writeLine. And we'll build this string up by saying, well, we'll just do I equals. And then we'll give it the black percent. Okay, I don't need this anymore. So this is really, let me just check that I'm still recording here. Yeah, so last time we tried Tesseract. This time we're trying to see if there's a fingerprint that the actual digits contain using only their black pixels. And this program will tell us. Let's find it. Let's see what happens. So what do we see? So look at the 6 and look at the 9. They're exactly the same. So this tells me that yes, indeed, the 6 is just an upside down 9. We will have to do something. If we get the value 58.176 blah blah blah, we still won't know if it's a 6 or a 9. So that matters a lot. Not if it's in the ones position of your score, but if it's in the hundred thousandths position in your score, that's a serious. That's between a 600,000 and a 900,000, almost a max out at 1 million points. But I already knew that. So let's see, 63 for a 0, 61 for a 3, 60 for a 4. Look at that. The 4 and the 3 are 0.5% off. So that might be a bit of an issue. So the 1 is going to be super easy to detect. The next one down, maybe I should, you know what? Let's sort these things. Yeah, so let's make a new, let's make new data equals. We'll just say string int decimal. I'm making a bucket right now that holds 2 values. The number that we're in. Whoops, a new list. Tuple. There we go. I'm gonna make a list of these things. And then we're going to get this, and we're going to data.add tuple.create the I and the black percent. Okay, that should work. And then we're going to, for each result in data.order by, and we're going to order by the second item, which is item 2. Then we're going to console.writeLine. Item 1, which was the integer, and the item 2, which is the actual percentage. Okay, so now we're going to get them in a order from least to most black pixels. And this will help us to see. So the 8, I was right, had the least black pixels. So between the 8 and the 2 is a 1.4% difference. Between the 2 and the 6 is a lot. 6 and 9 are identical. We knew that. 9 to 5 is only 0.5%, which kind of makes sense. You can see how the segments of the digit 5 could be rearranged to kind of make a 9. 4 is 1.4% above 5, so that should be, you know, reasonably far away. between 4 and 3 is only like 0.5%. That's not a whole lot. 3 and 0 are, that's pretty good. And then 0 to 7 is pretty big, and then 7 to 1 is pretty big. So I think what I'm going to find is that it's going to be fairly simple to distinguish the 8s and the 2s, the 6s and the 9s. Once we get into, you know, in the middle there, it might be tricky, but then again, 0.5%, remember these are 45 by 39. What is 45 by 39? There's 1,755 pixels to each one of these digits. And so, you know, even 0.5% is like 9 pixels, 9 extra black pixels on one than the other. And might be okay. Like, I think it's worth pursuing. I think this digital, or this black pixel fingerprint is worth pursuing. But we can also, like, the other thing I thought about was, is there a unique pixel on each digit that, you know, like only the number 2 has the following pixel lit up? So we'd only have to check 1 pixel of the digit. But that gets a little bit difficult when the character is, or the digit is slightly offset in the bounding box. Whereas the percentage wouldn't affect it using the percentage fingerprint, which is what I wanted. I wanted a little bit of a leeway there. So, okay. And that's why I went with this black pixel stuff. So I think this is okay. We'll pursue it. One of the great things about software development is that it's all going to be modular. So what we're going to do is we're going to build an engine that will recognize a digit, and we'll use it. And if later on down the line we realize that the fingerprint isn't actually working like we want to, we don't have to rewrite our whole program. All we have to do is rewrite our method that determines what a digit is. And there are, you know, various ways we could do that, but for now we're going to stick with this fingerprint. So I think what we'll do is we will use this. Obviously we're going to have to do something fancy to distinguish between a 6 and a 9. So that's going to be a bit of an issue. But we will, while they have the same number of black pixels, the black pixels are not in the same position. So the other thing we could do is break it up in half. So break the box, the whole digit up, you know, draw a horizontal line in the middle, and then find the percentages of both halves, and use those to determine a digit. Because you'll notice that the 6 and the 9 are the same black percentage, but if we chopped it in half, they would have very different, you know, the top half of the 6 would be the bottom half of the 9, so we'd be able to determine things a bit better. And the 8, of course, would probably be the same, but then again, we're not giving ourselves a nice error buffer either, so that's a bit more difficult. But I think these values are good enough. We'll see what goes on from here. Anyway, thanks for joining me. Next time we will use this fingerprint idea to start analyzing. We'll create something that can take multiple blocks of these digits and turn them into a number by recognizing them. So let's see if that works. Okay, Thanks for joining me. Have a good day. We'll see you next time.